Hello everyone, this is my presentation over the Lab 3 bar magnets. The purpose of this experiment was to measure the distance relationship between a magnetic field due to a small bar magnet and use Biot-Savart law for these relationships. For the results, we found that n was equal to negative 3.1193, mu was 2.1, and the net magnetic field was 5.89 times 10 to the negative fifth Teslas. Here's the Biot-Savart law, and we also have the equation for the magnetic field of a ring, and we also define mu. So the experimentation, we have the system and surroundings. For the system, we have a bar magnet, and the surroundings is everything else. So first we need to calibrate the magnetometer app. Then we need to identify the magnetometer sensor on the phone through the steps shown on the right. Take distance measurements that produces a magnetic field with various x component of magnitudes. Then we want to measure the off-axis magnetic field. Here's the experimental data, and if you go up and to the left of the image on the right, it shows the distance measurements that produces a magnetic field with various x components of magnitudes. On the top right, we have the linearized plot of the magnitude. That's showing magnetic field versus distance. And then the bottom image shows the off-axis field data. Here are our calculations. So the equation that we got was negative 3.1193x minus 14.685. The slope is from the equation above. We found k to be 4.19 times 10 to the negative seventh. And then using the Biot-Savart law, we were able to find mu, which was 2.95. Some observations were that when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnetometer moves closer to the magnet, the measured x component of the magnetic field actually increases. Here's the code. And the code generates a computational magnetic field of 2.1165 times 10 to the negative fifth, which is about half our observed, which is 5.89 times 10 to the negative fifth. And here's the model on the right. Some questions for this lab are: if you haven't oriented your experiment to compensate for magnetic north and it has said laid out your meter stick at some intermediate angle with respect to Earth's magnetic field, how would your results have changed? And simply put, the results itself would have changed due to the Earth's magnetic field. If you were to stick two identical magnets together, end to end, and run the experiment again, how would you expect your experiments to differ? The measurements would be larger due to the superposition that increases the magnetic field.